Okay, so next, let's recall. Sulat lang natin that V of R, or let's say X na lang. Negative O to X E dot dl. So, in general, ganito any coordinate system. Pero let's say, mag-spherical na lang muna tayo. So, V of R equals negative O to R E dot dl. So, now the question is, plus ano to? Ano yung reference point O? So, plus dun sa, kunwari, nag-classical mechanics. Pag MGH, potential energy, di ba usually yung O natin dun is yung ground level. Yun yung, at that point, zero yung potential. So, we set O such that the potential at this point is zero. Okay? So, set O such that at that point, V equals zero. So, at that point, V equals zero. So, anong point to? So, di ba kung isipin nyo, at infinity, nawawala yung potential ng isang, kunwari, point source. Di ba at infinity, wala, na nagiging zero yon yung potential nun. So, in this case, actually, yung O natin, let's set it to infinity. So, V of R now equals negative infinity to R E dot dl. Tinanggal ko na yung arrow class para mas madali nyo ma-imagine na lang. Ang hirap kasi pag yung bound mo, vector, di ba? So, kunwari R na lang. Hindi siya dependent sa theta and phi. Usually naman yung problems natin, independent of theta and phi. Some problems. Okay? So, okay, example tayo. So, we find the potential, find V of X inside and outside a spherical shell of radius R with a total charge Q. So, meron spherical shell na naman. Ang hirap mag-drawing ng bilog. Ayan. Meron kang radius R. Tapos may total charge Q. Okay, so, recall E out, ay, E outside ano yun? For 1 over 4 pi epsilon naught Q over R squared R hat. Okay? So, we have V of R equals infinity to R E dot dl. This is negative integral ng infinity to R ng 1 over 4 pi epsilon naught Q over R prime squared dr prime. Class, bakit ginawa kong R prime? Kasi, paano ba to? Si R to. R yung bounds natin, tapos yung variable R. Ang pangit tignan. So, ano lang, gawin na lang natin R prime, di ba? Dummy lang naman tong nasa loob ng integral. Para yung result niya, R na lang. Okay? So, this is 1 over 4 pi epsilon naught Q over R. Kasi, negative 2, so magiging negative 1 over R siya, maging positive. Tapos, pag infinity, mag-zero yung second term. Okay, this is the potential outside. So now class, what is the potential inside? Recall that E in equals 0, di ba? Using Gauss's law. The electric field inside this spherical shell is 0. So, we have V of R, ay, isa pa pala, kung outside, tignan nyo, manggagaling akong infinity, pupunta ako at some point R. Tama? Pero kung potential inside yung hanapin ko, from infinity, pupunta ako sa surface, then tatagos ako paloob. Okay? So, yung potential natin, merong dalawang contributions. Isa dito, tas isa dito. Bakit class hinati natin? Kasi magkaiba yung value ng electric field outside kesa sa inside. Okay? So, yun lang. Hinati natin yung integral. So, bale, we get V of R equals negative infinity to R E out dot dl minus, sige, plus negative para mas malinaw. R to R E in dot dl. So now we have, this is negative infinity to R 1 over 4 pi epsilon naught Q over R squared dr minus ito, R to R now 0. So we get 1 over 4 pi epsilon naught Q over R, ay, small r lang, running from infinity to R. So this is 1 over 4 pi epsilon naught Q over R. So yan yung potential inside. Napapansin nyo, ito, constant lang siya class. Constant yung Q, constant yung R. Then sa previous, ito, 1 over R siya. So, hindi siya constant. So, class, bakit constant lang yung potential inside? Tignan nyo class, di ba E equals negative del V? So, ang electric field inside, kunwari, kunin nyo yung gradient nito. Anong derivative nito? Di ba 0? Tama lang kasi 0 yung electric field talaga inside. Kaya constant yung potential. Okay? So, tandaan nyo, kapag constant ang potential, 0 ang electric field. So, dito naman sa previous, kapag kinuha mo yung gradient nito, babalik ka dun sa kq over r squared na electric field. Okay. So, next, let's discuss Poisson's equation and Laplace equation. So, recall, E equals negative del V. So, class, ano ang divergence ng E? So, del dot E, bakit? So, del dot E equals del dot negative del V. Yan. So, this is negative del squared V. Yan yung Laplacian natin. Pero class, recall that del dot E is also equal to rho over epsilon naught. Rho is your charge density. So, therefore, we have del squared V equals negative rho over epsilon naught. This is your Poisson equation. This is Poisson equation. So now class, special case, if the charge density equals 0, we have the Laplacian of the potential, del squared V, equals 0. This is your Laplace equation. Mukha siyang madali, di ba? Kasi del squared V equals 0. Pero class, later on, we'll see that medyo mahirap mag-solve ng Laplace equation. Okay, so nasan na tayo? Let's say, meron tayong, saan na yung previous? Next. Ay, delete ko nga to. Delete yung empty page. Okay, so next page tayo. In general class, we have V of R equals 1 over 4 pi epsilon. Ano to discrete point charge, Q over R. Tama? Kapag wala na sa origin yung charge natin, script R na siya. So kung for several point charges naman, we have V of R equals 1 over 4 pi epsilon naught summation I equals 1 to n Q sub I over R sub I. So for continuous distributions, hindi na siya uh, hindi na siya sum, integral na siya. So we have V of R equals 1 over 4 pi epsilon naught. Ay, sige class, gawin ko ng general case. So, V of X na lang. 1 over 4 pi epsilon naught. Para any coordinate system, ma-apply siya. Lambda DL over script R. This is for linear charge density. So, V of X equals 1 over 4 pi epsilon naught. Integral. Ay, wait class. Yung script R, gawin natin mas general. Gawin natin x minus x prime. Okay. Then this is, ayan gulo. So we have lambda of x prime dx prime over x minus x prime. Okay? So sa surface naman, we get sigma of x prime dA prime over x minus x prime. This is surface. Next, we have V of X sa volume naman. 1 over 4 pi epsilon naught integral ng rho of x prime d cube x prime over x minus x prime. So class, bakit ko sinulat as ganito yung may prime na? Kasi, tignan nyo, V of x lang. Again, take note yung prime coordinates, ayan yung source natin. So, lambda as a function ng source, x prime. Then, over x minus x prime, ito yung separation vector natin, magnitude. Then, i-integrate natin over the source. Bakit? Para magandang, actually class, ito yung ginawa ko kanina. Teka lang, sana yung previous. Yung, ito. Ganun, prime coordinates to. Ito yung source, kumbaga. Ito yung gusto nating, ano ba tawag dito? Ito yung location kung saan gusto natin kunin yung potential, yung R. Yung prime coordinates, yun yung source. Ini-integrate natin over the source. Okay? So, next. Kaya ganon. Yung nasa loob ng integral ay source. Tapos matitira na lang yung V of x prime. So, para in general, ganito. Mas maganda siyang tingnan actually. Kasi hindi siya nakakalito din. Okay. So now, I take note scalar ang V, hindi siya vector. Kaya wala kang R hat dyan. Okay. So now, okay, kailangan ko pala magbigay ng problem set. So, yan muna sa ngayon.